Imagine you are on a ship out at sea or flying a plane high above the clouds with absolutely no landmarks in sight. How do you find your way? You use bearings. They are incredibly useful for navigating the wide open world. So, what exactly is a bearing? It is simply an angle, but with two strict rules. First, it is always measured clockwise from north. Second, it must always be written using 3 digits. Let's look at how this works in practice. In this diagram, we have 2 points, A and B. When a problem says the bearing from A, it means that your starting point, your center compass, is exactly at point A. Now, let's look at the angle itself. The bearing of B from A is 052 degrees. Notice how we write it as 052 instead of just 52 to keep our 3-digit rule intact. What if we go backward? The bearing of A from B is 232 degrees. To see this, we draw a new north line straight up from point B, and measure all the way clockwise until we point right back at A. Let's put this to the test with our first example. The bearing of a ship from a lighthouse is 065 degrees. What is the bearing of the lighthouse from the ship? Let's sketch it out. If you draw a diagram showing the lighthouse and the ship, you will see something amazing. There are 2 equal alternate 65-degree angles formed between the 2 parallel north lines. Because the north lines are parallel, the total bearing of the lighthouse from the ship is exactly 180 degrees bigger than the bearing of the ship from the lighthouse. We just extend our straight line down. Now, we just add them up. It is therefore 65 plus 180, which is equal to 245 degrees. And look, it is already a perfect 3-digit bearing. In general, if you know the bearing from A to B, to find the bearing of B from A, you either add or subtract 180 degrees, depending on which one gives you an angle between 0 and 360 degrees. Remember, a bearing is always measured clockwise from north. Often, you will be required to use your knowledge of trigonometry to solve bearing questions. Let's take one more example. A ship sails 22 kilometers from A on a bearing of 042 degrees to point B, and then a further 30 kilometers on a bearing of 090 degrees to arrive at C. What is the distance and bearing of C from A? Get the bearing accurate to the nearest degree. First, draw a clear diagram labeling any extra points that may be helpful, then work out a general strategy. If you knew the length of AE and CE, you would be able to find the answer. But notice that AE equals BD plus 30, and CE equals AD. So, you need to find the lengths of BD and AD first. Let's find the length of BD using sine. Sine of 42 degrees equals BD divided by 22. Rearranging this expression, BD equals 22 multiplied by the sine of 42 degrees, which calculates out to 14.72 kilometers. Next, let's look at cosine. Cosine of 42 degrees equals AD divided by 22. This gives us AD equals 22 times cosine 42 degrees, which is 16.35 kilometers. Now we can find the complete side AE. AE equals 14.72 plus 30, which gives us 44.72 kilometers. Now that we have the sides of our massive right-angled triangle, you can work out the direct distance AC using Pythagoras' theorem. AC square equals 44.72 square plus 16.35 square. Taking the square root, AC equals 47.62 kilometers. We are almost there. To get the direction, we need angle CAE. Angle CAE equals the inverse tangent of CE over AE, which is inverse tangent of 16.35 divided by 44.72. This gives us an inner angle of 20.08 degrees. Finally, remember that bearings are measured clockwise from north. The bearing of C from A is 90 degrees minus angle CAE. So, 90 degrees minus 20.08 degrees equals 69.92 degrees. Rounding to the nearest degree gives us a final true bearing of 070 degrees. From local vectors to long-distance oceanic pathways, mastering bearings is simple when you map it out step by step. For more elite geometric breakdowns and masterclasses, make sure to like, subscribe, and journey with us at My Concept Cafe.